This is section 10.2, Pythagoras' theorem in 3 dimensions. So it starts from grade A and goes to A star, depending on the complexity and what other topics are roped into 3D Pythag. Just projecting ahead, when we do trigonometry involving sine, cosine and tangent, there is higher trigonometry involving further rules, and usually when they do 3D scenarios there, they tend to rope in Pythagoras as well. So in a rather complicated question, you can be tested on Pythagoras and trigonometry in 3 dimensions within one question itself. So just look forward to that one. For now, if you can see in 2 dimensions, you've got grade C. If you can see in 3 dimensions and do Pythagoras, you can get a grade A. So here's a starter question. This is question 1 on page 159. The diagram shows a cuboid in which AB is 11. It's merely describing the question. BC is 7. And the height CG is 4. So all these vertical heights here that I'm just highlighting are 4s. All the lengths across here are 11s. I'm sure you know that's just a cuboid. And all the lengths going into the screen like that are 7s. So I say into the screen because I'm like pointing my pen towards the screen, into the screen. And they're all 7s. That was a fly, not a wasp. I'm lucky there to shut the window. Right then, calculate the length of AC, in other words the one across the bottom here. Let me just draw it in with my little facility and highlighting in red. So A to C is that length right there. Now can you see, I hope you can see, we have a right angle triangle right here and it's sitting on the floor, right? So we've got a base of 11, a height of 7, and AC is effectively a hypotenuse. So if you can't see it, I've effectively got one of these. That's 11. That's 7, and the hypotenuse from A to C, the large length, it's that red one there, is what we're about to work out. And if it helps you to decode this 3D representation on a flat 2-dimensional surface, being the screen now, redraw it in a way that you can see it and feel confident about it. So effectively what we're doing is working out the length AC and it's a hypotenuse. Now just do it in one step. If we've got the 2 little sides, we square them and add them, don't we? And that will be x squared. Now if we press the square root straight away, we're going to get the answer for x, aren't we? Just keep it nice and simple. So it's 11 squared plus 7 squared, and then whatever the answer is to that, you square root it. Now I'm going to try and do this in 1 or 2 steps. So I've got 11 squared plus 7 squared. Obviously I know how to do this. Comes to 170. So let's just go root 170, and that's going to give us whatever the root of 170 is. That gives me 13.03. I just want to go to 1 decimal place, I think, so 13.0 would do fine, and that's in centimetres. And that's AC done. Alright? BG, well, B to G is right across there like that. Let me just grab a different colour. Hopefully that would stand out if I use this facility. So B to G, from that corner to that corner. And this time we're still doing a hypotenuse, but we have a base of 7 and a height of 4. So if you'd like me to draw that for you, this is what we're doing. I've got a base of 7, there it is just there, so I'll draw in a 7. I've got a height of 4. This time it's the true height of the cuboid, as opposed to the 7 that was the height before. And that's 4, as I said. And we're effectively working out the length from B to G. And that is, as you can see, another hypotenuse, so we can call that x as well. And if it's a hypotenuse, we just take the 2 smaller sides, square them, add them, press the square root button. There's our answer in one go. That's 49 plus 16 gives me 65, so x is going to be the square root of 65, and that's going to be whatever it is. Hit the square root button. 8.06, so it's about 8.1 to 1 decimal place. That's in centimetres. Right, C to E, that's coming right across here. Right, different colour again. Let's pick something that works. I tend to go with these greeny affairs, don't I? Right, we're going CE, so it's from here to here. So it's the top left down to the bottom right, or rather bottom at the back. Now watch out, watch out, watch out, watch out. Let me highlight this carefully. We have the triangle AEC. Alright, one more time. AEC. We know the length of AC because we've worked it out here, and we know the height of AE because they're all 4s, aren't they? Therefore we can work out CE or EC, which is the hypotenuse of the triangle AEC. That's right angled, of course. We know this is 13.0 or just 13. We know the height here is 4. So effectively I've got a triangle that goes like this. I've got a 4 vertical, I've got a 13 which is the base, and I've got E to C like that, which is yet another hypotenuse. Call that X. So straightforward. X is going to be 13 squared, the base, plus the 4 squared, the height. Then we square root it. Just do that quickly. So it's 169 for 13 squared plus 16 equals 185. So the square root of 185 is going to be something. Comes to 13.6 to 1 decimal place. So I'm very happy with that as a good starter question. Alright, so I might get one more on this or not. Yeah, let's do question 2, I think, on the other page. Alright, so all we've done is worked out hypotenuses. Don't think that's the correct plural, but it's the best I can do at the moment. And as you can see, essentially we're doing Pythagoras in 3 dimensions. You need to extract what you know. Draw little triangles, you know, here, here and here, if it helps you to see it better in 2 dimensions, and go and get your grade A. Dead easy. Right, I missed out question 2. I've gone straight to question 3. I'll do this one and then probably pause for the more challenging ones. So question 3, here it is. It says the diagram shows a pyramid with square base. Now, I need to know that a square base. Essentially, if that's 15, then guess what? So is that one as well. And of course, that's a 15, and that's a 15 at the back. I may not need all these facts, but I'm going to need some of it for sure. Otherwise, why tell me it's a square base? Okay, so square base of side 5 is 15 centimeters. The vertical height directly above the center of that square is 10 centimeters. I've got to calculate the length of BD. Lovely. So let me just get my straight line facility. BD. Let's do it in the direction it says. Straight across there. As you can see, the vertical height is directly above the center of the line between B and D. There it is. They've actually drawn it rather well. So I've got to work out this length. Fair enough. Okay. Well, if we look carefully, if we have a square base and this is a square, I've got a 15 going into the page or into the screen from A to D. I've got 15 along the base, A to B. So if this is a square, then that actually is a lovely, get my pen on, is a lovely right angled triangle. Alright, so I'll draw you what I've got here. I've got 15, that's that one right there. I've got 15 here at the front, A to B. So let's just draw it in. I've got A, B, that's 15. We're given that in the question. I've got B to D being, A to D being also 15 because it's a square, and I've got the length that they want me to get, which is clearly a hypotenuse, called DB. So we can call that X, can't we? So there we go. A to D, D to A to B, 15, 15, and let's work out the hypotenuse, and that's the length BD or DB. Straightforward. Let's just do it quickly. So do it underneath here. I've got loads of space. So X is going to be the 2 little ones squared, and they both happen to be the same because it's in fact a square base. Then just square root it. 15 times 15, I think that's 225. Yep, so let's have another 225. Gives us 450. Now we're going to square root that. So let me just write down root 450 first to show an intermediary step. Now we're going to square root it and get 21.2. It makes good sense because 21.2 is in fact the hypotenuse, the longer side of this triangle here that goes DAB. Alright, so that's the length BD sorted. Now the length, is that correct? Of course it's correct, it's wonderful. Now we're going to do the length YB, from Y to B. Alright then, I can do that. So look at it. We've got another little triangle. Look, that's at 90 degrees. I know the vertical height is 10. I know from B to D, D to B, we've got 21.2. So therefore, this part here, this part is going to be half of 21.2. So 21.2 divided by 2, I'm going to call that something or other, because I'm allowed to use a calculator. So that's 10.6. So what have I got? I've got a, if you like, a base of 10.6. I've got a height of 10 because I've been told that's what I've got there, the pyramid, and I've got to work out the missing length, which is VB, and there it is. And so we can call that X, can't we? Again, yet another hypotenuse. These questions have not got harder yet in terms of finding the shorter side, but anyway, let's just work with it and just get better and better. Again, X on its own is going to be 10 squared plus the 10.6 squared, the two smaller ones, and then we're going to square root them. So 10.6 squared is that. I'm going to add on 100 because that's what 10 squared is. So I've got the square root altogether of 212.36. I'm now going to press the square root button and get my marks. There it is, 14.5. Well, to one decimal place 14.6 then. That's good enough. Am I happy with that? And just check that, 20 across there, halve it. Yeah, pretty good. I'm happy with that. So there we go. We have a hypotenuse YB of 14.6. And I'll stop there. Look at the video again because it won't get easier. It will get tougher as the scenarios get more challenging and even more 3D-ness in their approach to the problem. So have a good look, and before we go any further, study this one and learn how to extract 2 dimensions from a 3-dimensional representation.